We've been learning this unit about sequences, lists of numbers, and series, sums of sequences. So we're going to continue that investigation today. Let's start out by adding up odd integers. So since we're adding, we're going to be talking about the sum. So what would the sum be of the first odd integer? Well, the first odd integer is just 1, so if we add that up, we end up with 1. The sum of the first two, 1 plus 3, is 4. The sum of the first three, 1 plus 3 plus 5, is 9. Sum of the first four, 1 plus 3 plus 5 plus 7, is 16. And the first 5 is 25. Now take a look at these sums. 1, 4, 9, 16, 25. Looks like we have a pattern here. That's interesting. Here we are using series to add these up. We're actually creating a new sequence, or so it seems. So what is that pattern? S sub n. So if we add up the first n odd integers, well, it would start with 1 plus 3 plus 5 plus, going to continue. What is the formula for this sequence we're creating? Well, let's see. You're adding 2 each time, so there's a common difference, means it's an arithmetic series. So that would be 2n, and then the term right before 1, the 0 term, negative 1. So this is our first term, our second term, our third term, all the way up to the nth term. And based on these numbers here, let's see, 2, 4, 3, 9, 4, 16, 5, 25, n. It looks like the pattern says this would equal n squared. Unfortunately, seeing something repeat 5 times in a row is not enough to mathematically prove that it's true. Maybe we get up to the 10th term and it doesn't work. Or maybe the 100th term, or maybe the 1000th term. We just don't know. So here's our job today. We want to prove that this is true. The process that we're going to use to prove it is called mathematical induction. Mathematical induction is used to prove that a statement about positive integers is true. So they have to be positive, so 1, 2, 3, 4, 5. And they have to be integers, so whole numbers. So notice the numbers we used as we were developing this pattern. 1, 2, 3, 4, 5, and so on. So n stands for some positive integer. Now I hope that you watched the coin domino link that I put up on the website. We just saw this amazing number of coins fall over. But if you were ever little and set up those dominoes, remember there's 2 things that had to happen in order for your dominoes to fall over. First of all, you had to make sure that as you set them up, each domino was just lined up so that when one fell over, it would hit the next one, and the next one, and the next one to cause that chain reaction. Once you had them set up, you also had to go knock over that very first domino in line. That's kind of the basis for mathematical induction. Here's how to use mathematical induction. let S sub n be a statement involving the positive integer n, just like we have up here. It's a statement and it uses n. If the statement is true for S1 and knowing Sk is true implies Sk plus 1 is also true, then the statement is true for all positive integers n. Like I said, two things have to happen. First, you need to make sure that it's true for S1. So if we look at our odd integers up here, well, we look like we had a formula that the sum will always be n squared. Did it work for the first number? Well, let's see, 1 equals 1 squared. Yeah, we're good. And knowing Sk is true implies Sk plus 1 is also true. Well, it's a little bit harder to show from here, but that would be like saying, well, I know that 1 plus 3 plus 5 plus 7 is 16. Does that mean that if I add the numbers from 1 to 9, odd numbers from 1 to 9, I'll get 25? Well, yeah, if I add 9 here and add 9 here, it works. So I've shown that since this one is true, the next one is true as well. Now we're going to have to be a little bit more precise about it, but that's kind of the idea behind induction. Now, in order to do this, we are always going to have 3 steps. The first step is called the anchor step. And that is where you show S1 is true. In other words, that's where we're going to knock over our first domino. The second step is called the induction hypothesis. That is where we assume Sk is true. And our third step is called the induction step. And that is where we show Sk plus 1 is also true. So induction hypothesis and induction step working together show that if you knock over one domino, the k, the next domino in line, k plus 1, will also knock over. Now before we get into a proof, I want to make sure that you understand what S1, Sk, and Sk plus 1 mean, and are proficient at plugging them in and doing some of those problems. So let's try that. So here's what we need to do. Let's practice writing the statements S1, Sk, and Sk plus 1. So first, let's take S sub n equals 6 over n times n plus 3. So S1, well, let's see, we're just plugging 1 in for n. So 6 over 1 times 1 plus 3 is 6 over 4, which is 3 over 2. To find Sk, we're going to plug k in for n. 6 over k times k plus 3. Can this be simplified at all? No. So we're done. And finally, sk plus 1, we're going to plug k plus 1 in for both of these n's. 6 over, I always recommend when you plug in k plus 1, put parentheses around it. So k plus 1. Now if I put parentheses here, these outer parentheses will become brackets. That would be sk plus 1. Can this be simplified? Sure. Inside the parentheses, or inside the brackets, we have our parentheses, but the only thing this is being multiplied by is a 1. So we have k plus 1 plus 3, k plus 4. And again, notice there's no proof here, there's no big problem. We're just practicing plugging these in. Next, let's take a series. S sub n equals 1 plus 5 plus 9 plus 13 plus 4n minus 3. So this is the sum of the first n terms. So when we say S1, we're saying what is the sum of the first term? Well, our first term is just 1, and that's all you need to do. Sk would be the sum of the first k terms. So you have to start at 1, go all the way up until you plug in k. 1 plus 5 plus 9 plus 13, all the way up to 4k minus 3. And finally, sk plus 1. 1 plus 5 plus 9 plus 13, all the way up till 4k plus 1 minus 3. Okay, before we get into an actual induction proof, I recommend you find induction worksheet number 1 and practice problems 1 through 4, which has you doing exactly this, making sure you know how to find S1, Sk, and Sk plus 1.